This lecture discusses how to interpret results from binary regression models. Because of the nonlinear nature of this model, we don't have a one-size-fits-all type of measure like the OLS estimator in the OLS regression, right? Because in OLS regression, we can simply grab that coefficient or slope for any generic variable, and we say, well, for each unit increase in that generic variable, we would expect y to vary by that beta amount on the scale of observed y, right? Depending upon the sign of this beta, we can either say increase or decrease. Unfortunately, we don't have that in binary regression model as shown in previous sessions. The problem is that, in short, is that the predictions and the effects in binary regression models vary with X vector. It is vary with a row of X values for covariates. And here I'm talking about the majority of measures of predictions and effects. There are exceptions. For example, odds ratio coefficients. Later on, I'm going to talk about. Right? Later on, I'm going to talk about. And here, based on my own research, I want to talk about a 2 by 2 by 2 interpretation typology in binary regression models. First is measures based on prediction versus measures based on effects. When we say prediction, in most cases, it refers to the predicted probability or odds, or sometimes rates in count regression models and survival time in survival regression, or predicted probabilities in ordinal regression models, order regression models, and multinomial regression models that we will cover later on. So here we could have prediction measures based on the response variable. Sometimes it's predict probability, other times it's rates and survival time for more advanced categorical and limited response variable models. And another type is effect, okay? Measures. And these measures are used to talk about the effects of covariates or explanatory variables on the response variables, on the observed scales and sometimes predict probabilities. And these measures usually include, while for binary regression models include odds ratio coefficients and partial or marginal effect. And the second dimension is what I call local versus global measures for interpretation. When I say local, it means measures based on a single or a few limited cases. So it could be a predicted probability given the X vector at a hypothetical or observed location, either within or out of sample. Second is global measure. Global measure or measures refer to statistics based on a large number of sometimes observed cases. Okay? So sometimes it's based on all cases in estimation sample, sometimes half, and sometimes cases, these statistics are based on cases for some subgroups in the estimation sample. For example, average marginal effect. Average and marginal effect. A third dimension, okay, kind of dyad or dyads, or dimension for measures of interpretation in binary regression models is the ratio versus difference measure, ratio versus difference. So when we see ratio, basically, we take a ratio of two statistics. Sometimes could be probability, sometimes could be effects measures, such as odds ratio coefficients. Here I give a couple examples like odds ratio, so take a ratio, risk ratio, so two probabilities, right? A ratio of two probabilities. Or it could be a ratio of predictions or effects. Could be a ratio of, see here, here I'm going to use marginal effect, global measure, ratio of average marginal effects, okay, from two different groups. So that measure involves ratio, and involves global, and involves effect. So effect, global, and ratio. Another possibility, a second possibility is difference measure. That is difference in predictions or effects. Simply we take a difference of two statistics and we go from there. So this is a typology, interpretation typology that I came up with in one of my publications and a book manuscript that I'm writing. And I believe this typology is very useful for the use of different kinds of measure statistics to interpret results from binary regression models.